Hello, this video is going to go through an OCR F324 January 2011 past paper, organic chemistry, specifically looking at carbonyls to start. So, typical examiner fare, they give you a chemical that you've never come across before, and what you've got to do is stay calm. They give it a name, very exciting, and then they give you the structure, and then they also give you some key information pointing out that it's got an aldehyde in it. Looking around, there's also a couple of double bonds, and the rest is just single carbon and carbon hydrogen bonds, so you know it's not going to be doing much from the chemistry we've learned. A chemist undergraduate investigates some reactions. Okay, let's keep going. Prepares a solution of Tollens reagent and added a few drops, warmed it for 5 minutes. So you have to know that Tollens is the test for aldehydes. Tollens includes silver 1+, and if we describe what you'd expect the chemist to see, well, that silver 1+ is going to get reduced, and what you will see is silver, and then a mirror is the best way of putting it, but a silver solid is quite often going to get you the mark. You might also get away with putting AG, but best to put the silver mirror. So, double checking. This is worth 3 marks for us. Okay, well, that's the first thing, that's going to be 1 mark. The type of reaction. The silver is being reduced. It is therefore oxidizing. So, oxidation is what you want. Yes, it's redox, but it's specifically going to be oxidizing this chemical here. And the third thing, draw the structure of the organic product. Well, I've put in all of the single bonds already because none of them are going to change. We know that Tollens is not doing anything to the double bonds, so I can put them back in, and it oxidizes aldehydes to carboxylic acids. So whenever you get a question with Tollens, you take your aldehyde and you turn it into the carboxylic acid, and all the rest of the molecule, no matter how complicated, is going to stay the same. Right, question 3b, from oxidation to reduction. The chemist reduced safranal using an aqueous, that's going to be important later, solution of NaBH4. So NaBH4 is ionic, splits into sodium plus and BH4 minus, and it's a source of the H minus ion, the hydride ion, and this is a really reactive chemical. They want you to outline the mechanism below, and you can use R to cover all the rest of the molecule, as we know that only areas that things are happening are at the aldehyde. Now it's crucial, read the full set of instructions, curly arrows and relevant dipoles. So they also should ask you to include lone pairs. So I've put my lone pair on my hydride. So over here, delta negative on the oxygen, delta positive on the carbon. That is the dipole they want, and the curly arrow is the movement of a pair of electrons, so it's always starting at a lone pair of electrons, and so there are some lone pairs in the oxygen, but that's not where it's going to happen. Here it's a nucleophile going to be attracted to the delta positive carbon, so I'm drawing my curly arrow from the lone pair in the H into the delta positive carbon, and that would have got you the first mark for this. Now the carbon at that point would have 5 bonds. It can't have 5 bonds, so a curly arrow starting in the middle of one of the double bonds and going onto the oxygen atom. That, combined with the dipole, gets you the second mark. Right, you've got to have an intermediate here. You draw everything that hasn't changed in. There was no longer a double bond, it will now be a single bond to the oxygen, and it's gained electrons, so it's now negatively charged, and because the hydrogen has given the lone pair into the carbon and now makes a bond, it no longer has a charge. You can see before there was a neutral species and a 1-, and now 1-, so it balances out. So this is the intermediate, it's the third mark. Now, because this is non-polar, we're not going to get addition elimination. For aldehydes or for ketones, the next step, this aqueous part, is going to be important. The next step involves turning this into an OH, and we do that because we've got a delta positive hydrogen on water. Now if they said that you added acid at this point, you could just put in H+, but because it's aqueous you have to show it from a water molecule. Again, a curly arrow from the lone pair on the oxygen to the hydrogen, and then the bond from hydrogen to oxygen has to break as the oxygen from the water pulls the electrons towards it. You can't have a hydrogen with two bonds. So final thing, everything that hasn't changed, R to the C to the H, that newly formed H down the bottom, and then up here we've now got an OH, so we have reduced it from an aldehyde to an alcohol, and here we have hydroxide as the byproduct. And so this part here was the fourth mark. Okay, last part of this question, part C, suggests one reaction of safranal does not involve the aldehyde group. You have to state the reagent, the observation if any, and then draw the organic product. Okay, so I've drawn the molecule out again here so that we don't have to keep turning the page over in the video. And we know single bonds to carbon and hydrogen, not much going on there. Can't involve the aldehyde, so all that's left are these double bonds. And they've been a little bit sneaky here because they've put the double bonds in the cyclic system to make it look like it might be aromatic, but there's only two double bonds. So you are not going to get the aromatic, the benzene reactions. These are going to behave just like a typical alkene. So the reagent for testing for a double bond is Br2. You can of course write bromine. And the observation is, the test for alkenes is that they decolorize the bromine, and hopefully you get the mark for that, but if you do know the colour changes, put them in. So it's from orange to colourless. Checking the marks, 3, they've made it nice and easy, they've put 1, 2, and then the third thing they want is the organic product. So I have drawn the molecule with everything that has no part in this reaction in place, and there were two double bonds, so I'm going to add bromine to both of them. Remembering, as I said, this is an alkene, so we're doing electrophilic addition, we're not doing the substitution reaction that you get for benzene chemicals. The examiners this year were very generous and they allowed you to only add bromine at one or the other, didn't matter which, or you could do both, so there were 3 possible products. Thank you.